Here is a real simple way to make a very inexpensive high voltage power source using an old computer monitor. This one's about 10 years old. There's 4 screws that hold on the cover of the back. There's 2 on the sides. You just pull these plastic things off and take the screws out. And you flip it over on the bottom, there's 2 screws that you can access right here. When you get the cover off, you'll see this. This is a Faraday cage wrapped around the electronics. You take that off. There's a few screws holding that on usually. And then when you take that off, you'll see the basic electronics on the bottom there. And there's the flyback transformer is what we're going to be looking for primarily. And also, when you be very careful when you take off the wire on the other end of the transformer, you may want to ground a wire to the frame of the computer and then touch that first and then pry that off. Here's basically what the circuit board looks like when it's off. Here's another view. Here's what it looks like on the other side. It's pretty complicated. And then you'll locate the area where the flyback transformer is, right here. And you'll get yourself a Dremel with a small cutting blade on it, about a 1-inch blade, and you'll just start cutting carefully. Cut that thing out. When you cut this out from this side, should just fall out once you cut all the wires off it that you don't need, and then you'll want to trim around those wire connections very carefully so that you can connect to those. Also, here on the circuit board, you can see those 2 those green items. We're going to be cutting those off too. Those are big ones. Also, this transistor on the far right we're going to be using, so we're going to cut that L-shaped bracket in half, and that heat sink we'll use. Here's some components that we salvaged off of that, some wires and things and resistors. Here's a picture of that transistor with the connected with some of the fittings wire connectings we used. Here's the base of the computer monitor that we're going to use for our platform. And here's an on-off switch that was salvaged off of an old discarded ceiling fan. Here's the wiring. You may want to pause. Also notice where it says 5 turns, I use 7. I like to use 7 now. I find that works fine. Here it is all assembled and actually in operation. You can see the 2 big green resistors there, kind of on the right side. There's that 10-volt power supply. You can probably pick one up for $1 at a yard sale. Here's another view of that flyback with the wires. The green wires are of course 7, and the white one is the feedback is 2 wires. It's very effective. Here's locating the pin that has the ground. Just bring your hot lead around, and as you bring it up close to those terminals, you'll see the spark jump. And it's very interesting as you move the spark back. This is 5/8 of an inch, and as you move it back, it kind of makes like a wind type of sound. You don't see any more sparks. You just see this like flame coming out. It's pretty cool. Here's the actual spark, and you'll notice around that center electrode up inside there, you'll see a little bit of sparking up inside there too. I noticed that with both of my coils, that they were doing that, and that's 180 thousandths of an inch. It's like 3 times a normal spark plug gap. Here's the unit in operation, running to the grounding. But you can build it yourself. It's pretty simple. It takes some time and takes a little bit of perseverance, but it's not real complicated. And I'm sure that I don't have $2 in this high voltage, high frequency, self-resonating power supply.